All right. Good afternoon. Good afternoon. Hope all is well. Hope everyone's doing okay.
Good afternoon.
How's it going? How's it going? All right. So we're getting into chapter 10 today. Our last set of information that's going to be new for us. All right. So we're looking at hypothesis testing. So we're going to look at the language of hypothesis testing. First thing is hypothesis testing, or hypothesis is a statement regarding a characteristic of one or more populations. Hypothesis testing is a procedure based on sample evidence and probability used to test statements regarding a characteristic of one or more populations. All right. So steps in hypothesis testing. This is if you were to start from scratch. You're going to make a statement regarding the nature of the population, collect evidence, which is sample data, to test the statement, then analyze the data to assess the plausibility of the statement. All right, we scroll up. All right, so when it comes to our hypothesis, there are two pieces to it. There's the null hypothesis and the alternative hypothesis. The null hypothesis is denoted by HO or H naught. It's a statement to be tested. It's a statement of no change. I left the E off right there. It's a statement of no change, no effect, or no difference, and is assumed true until evidence indicates otherwise. All right, screwing up. Oh, I thought I had more than alternative. Okay, so the other part is alternative hypothesis. Oh, you said that, but I thought I had some more on there. Denoted by H1 in our book, and other books have different notation for it, but we will use H1. So it's a statement that we are trying to find evidence to support. Okay. Going down with alternative hypothesis. All right. So there are going to be 3 tests that we'll be able to perform. So get all of them in here. All right. So our two-tailed test. And notice you're going to make both of your statements. You have your null hypothesis, your alternative hypothesis. And if you look at all 3 of your tests, all of that is the same. We have our parameter equal to some value for your null hypothesis. That will always be the same. It's always going to be equal for your null hypothesis, no matter which test you're looking at. So our two-tailed test is called a two-tailed test because we have 2 tails that's going to be dependent upon the success or failure of what's true and what's not. And we'll see when we look at our test and actually executing the test. Our left tail will be the left side, and right tail will be this right side. You know, and like I said, we'll talk about what those mean in a second. But once again, going back to what is the same and what's different. The only thing that's different between the 3 tests is this symbol right here. Everything else is the same. So they're just like when we were dealing with z-scores. There were keywords to let us know we're dealing with to the right of our data value, you know, greater than, less than, would be to the left of our data value, and such like, you know, things of that nature. So there's going to be keywords that's going to let us know whether it be not equal to, less than, or greater than. So with these 2, it's going to be some of the same keywords when you talk about less than, greater than. But here you're talking about maybe different or not the same as, you know, that would be the keyword, let you know that it's not equal to, or in other words, a two-tailed test. So these are 3 tests that we will be performing. And once again, all of them are the same, except for this symbol right here. Scroll up. All right, so in this example right here, we're not looking to actually perform the whole hypothesis testing. What we want to do here is just determine what is the null and alternative hypothesis, and then state the test, whether it's test two-tailed, left tail, or right tail. All right. So Medco, the Medco pharmaceutical company, has just developed a new antibiotic for children. 2% of the children taking competing antibiotics experience headaches as a side effect. A researcher for the Food and Drug Administration wishes to know if the percentage of children taking the new antibiotic who experience headaches as a side effect is more than 2%. So I'll give you a chance to write it down for those who are doing some. All right, let's go up. All right, so this would be our null and alternative hypothesis. So notice this part is always going to be the same, HO over H1. The parameter that we're using here is percentage, so that's why I use P for percentage. Once again, the null hypothesis will always have equal, more than, it's greater than, and then 2% is the value that we're comparing. So notice those are the same here. So you have P equal to 2%, P more than or greater than 2%. And because it's greater than, it means it's right tail. All right, questions.
I did have a question.
Mhm.
And so for H0 or the 0.02, that's the line on the bell-shaped curve, and then the H1 just shows which direction it's pointing.
Well, what's gonna happen when we do our actual hypothesis testing, since it's right tail is going to tell us the shade right there, and we're going to have a z-score type situation where we're going to have a test statistic and everything like that. So this is just a statement, but that 0.02 is not going to have anything to do with our shading. This just lets us know that we're shading to the right, and we're gonna actually perform some z-score formula in order to be able to dictate this line, you know.
Okay.
So yes, a little more to it that we have to add. We have some more steps that I'm going to give you, but right now we're just establishing what is the statement, what's your null hypothesis statement, and then what you're trying to prove to be true. And so that's all we're looking at right now.
All right.
All right, pretty good with that. Before we look at the next one. All right, so the Blue Book price of a used 3-year-old Chevy Corvette is $86,012. Grant wonders if the mean price of a used 3-year-old Chevy Corvette in Miami is different from $86,012. All right, so here's the null hypothesis and alternative hypothesis for this one. Notice this time we're dealing with the mean price, so I use the mean symbol. I use mu. Once again, this is equal. The value that we were comparing is 86,012, so both of those will be that. So once again, both of these will have the same symbol. Both of these numbers will be the same. Equal will always be there. So what we need to establish now is this, and the keyword here is different. Didn't ask us about greater than, didn't ask us about less than. It could be either one of them. We just want to know, is it different? So that's not equal to. So that's why that symbol went there. And since it's not equal to, that means it's two-tailed. All right. Problems before I scroll up. Last one like this, the standard deviation of the contents in a 64-ounce bottle of detergent using an old filling machine is 0.23 ounces. The manufacturer wants to know if the new filling machine has less variability. All right, so this one we're using standard deviation, so that's why I use the standard deviation symbol here. That's what we're talking about. So notice in the first one we use P for percentage. The second one we use the Greek letter mu for the mean, and here we use sigma for standard deviation. Once again, equal to 0.23 is the number that we're comparing, and we use less than here, which is left-handed. All right, questions. Very good. All right. So there are 4 outcomes that could occur. You can reject the null hypothesis when the alternative hypothesis is true. And that's what you want to do. You know, if your alternative hypothesis is true, then you reject the null hypothesis. You do not reject the null hypothesis when the null hypothesis is true, of course, because if the null hypothesis is true, you wouldn't reject the null hypothesis. Now, the next 2 are errors that could occur. You would reject the null hypothesis when the null hypothesis is true. That's type 1 error. And you don't or do not reject the null hypothesis when the alternative hypothesis is true. So it's a type 2 error. All right, everybody okay? Then we have our level of significance. That's denoted by Greek letter alpha. The probability of making a type 1 error is our level of significance. Should have another slide. Any problems, any problems? Hold on, pulling up this color set. All right, so. All right, so we're still in chapter section 10.1, but finishing up those notes, talking about difference, the major difference between type 1 and type 2 error. So we have, like I mentioned already, alpha, Greek letter alpha is a probability of making a type 1 error with Greek letter beta, just like a B with a little longer stem. Greek letter beta is the probability of making a type 2 error. So the probability of making a type 1 error is chosen by the researcher before the sample data are collected. So now our problems will give us alpha, but it's just saying if you start from scratch, you can choose your own alpha. And you'll see why that makes a difference in a second. So the choice of the level of significance alpha depends on the consequences of making a type 1 error. So if the consequences are severe, alpha should be small. If the consequences are not severe, a higher alpha can be chosen. So alpha being 0.05 or 0.10 would be fine. The level of significance is not always set at alpha being 0.01 because reducing alpha increases the probability of beta. So they have an inverse relationship. So as one goes up, the other one goes down, and vice versa. All right. Questions. And go off the page. Everybody still copying? All right. So let's go here. All right, so here's our hypothesis testing. And we have two different approaches. Classical approach, p-value approach. All right, so we got 5 steps, no matter which approach you use. And I will shoot you guys this in the email, even though you have access to it in your book on, can't find my book. It's on the page, should be in 10.2. Might be in 10.1, but anyway, these are your steps. And so notice step 1, determine a null and alternative hypothesis. It could be two-tailed, left-tailed, or right-tailed. Then the level of significance needs to be determined. All of our problems will be given to us. And then from there, you find your test statistic. Notice the formula is still the same, but that's our z-score that we're going to use that will enable us to be able to continue on. Your wording will let us know whether we're, and that goes back to our null hypothesis versus our alternative. That lets us know whether we're two-tailed, left-tailed, or right-tailed. You know, the wording tells us that. And then from there, we'll compare the critical value to, you know, our p-value and our test statistic and all that good stuff like that. So I'll email this to you. And right now we'll go ahead and try some of this stuff out. Let me see if I can pull up. That will keep out of MathLab. Give me 1 second. All right. All right, so just give you an idea as to how some of these problems are presented to you. So this is 10.2. So number 3, they could just give you everything, and then ask you to perform the test using the p-value approach. So that's number 3. So we'll walk through that. But you see how they give you the information. They give you your null hypothesis and your alternative hypothesis, tell you what type of test you're dealing with, give you n, x, and alpha. And then from there, perform the test using the p-value approach. So let's look at a problem like that. All right. So this is my number 3 that I had before. And they gave us, once again, they gave us this information. And they asked us to perform the test using the p-value approach. So P naught is always this value up here, the value that you're doing your comparison to with your hypothesis test. To find P hat, we talked about that before. You take X and place it over N. So 95 over 150 gives me 0.6, and then 3 repeated. So now we can find our test statistic. This is the formula right here for it. And that formula is in the that page that I'm going to send to you guys. Once again, that page is in the book as well. But it's P hat minus P naught over the square root of P naught times 1 minus P naught over N. So that's what we did right here. And I simplified it a little. If you have a legit calculator, you can just plug it all in like this. But I was just doing it for the piece in pieces just in case someone didn't have a calculator that have parentheses and all that stuff like that. Because what you would do is put parentheses around this. That would be a numerator, and then if you put the parentheses in the right spot. And if you have any questions about how to use your calculator, always feel free to bring your calculator one day and show me what you have, and I can show you what to type in. All right, so I got negative 1.78. So everybody good. And notice that's Z naught, so that's a Z score. And that means we can go to the chart. And I didn't point this out. Let me point this out in the, just want to point this out real quick. Notice if it fits the criteria, then that means, where it go? And it must be on another page. Anyway, this criteria, we talked about it before previously, that lets us use the Z-score chart and its normal distribution. So that's why that holds true. We weren't asked to test it because we already have established that. That's why they give you this problem. But if you're doing it on your own, this relationship right here allows us to use the Z-score relationship and the normal distribution. So I just want to throw it out there. All right, so you go to the chart, negative 1.78, and we were looking at less than. So remember, if it's less than, the chart value is what we need. It's less than. Remember, if it's greater than, then we have to subtract that value from 1. And we have 0.01 as our alpha. They gave us that. So before I go back to those steps, is everybody okay with where we are so far? So far? All right, so going back to the steps. We're over here using the p-value approach. Notice it says if the p-value is less than alpha, reject the null hypothesis. And so in this case, our p-value is greater than alpha. P-value is 0.375, alpha is 0.01. So we do not reject the null hypothesis. So this one didn't have a word problem behind it. So, we don't have to come up with any wording. So this one just says we do not reject the null hypothesis. All right, any problems, any problems? Scroll up. All right, so let's see what 4 looks like. Oh, 4 is similar to the last one. So this time they give us, once again, H naught and H1. And they give us N and X and our alpha significance level. All right, did they tell us to test that? Let me take a look. Oh, okay, yeah. So this did add an extra step. So notice it says is N times P naught times 1 minus P naught greater than or equal to 10. So they asking us that. So that's why I had that first step in there. All right. So here we have P is equal to 0.81. P is not equal to 0.81 for alpha. Say for alpha, for our alternative hypothesis. So remember that not equal to is two-tailed, means we'll have two-tailed on a test. And they give us N is equal to 500, X is equal to 390, and alpha is equal to 0.1. First thing they want to know is N times P naught times 1 minus P naught greater than or equal to 10. So the answer is yes. So you would just plug in, let me see. Okay, so they tell you not to round. So evidently this ends, this is exact right here. So it says type out a decimal or an integer, but do not round. So this must be exact right here. So we did 500 times 0.81 times 1 minus 0.81. And you type in this value into that. All right, since that is true, we can go ahead and continue on. So X over N to give us P hat 390 over 500, give me 0.78. Not 0.78 minus 0.81 divided by 0.81 times 1 minus 0.81 divided by 500. So hold on to the purple. All right. So doing the calculation, we end up getting negative 1.71. All right, any problems? Any problems? So once again, go to the chart. And that's going to give us 0.0436. All right, so hold on 1 second. Yeah, that's all right. So we don't forget that we have a two-tailed test this time. And we got 0.0436 on this left side. But if it's two-tailed, that means we need a 0.0436 on the right side as well. So we're looking at negative 1.71 and then positive 1.71 for our z-scores that will create our boundaries for our two-tailed test. So both have to have that 0.0436 over there. So to calculate the p-value, we're going to multiply that by 2. So we get that 0.0872. Then you compare your p-value, and you only multiply it by 2 when you're dealing with a two-tailed test. So you multiply by 2, got 0.0872. Then you compare it to alpha. The alpha they gave us was 0.1. And so that means we will reject the null hypothesis. Questions or problems with the process? Let's scroll up. All right, so let's go back to that. Do at least one more. All right, so let's look at number 6. All right, so a certain drug can be used to reduce the acid produced by the body and heal damage to the esophagus due to acid reflux. The manufacturer of the drug claims that more than 89% of patients taking the drug are healed within 8 weeks. In clinical trials, 208 of 237 patients suffering from acid reflux disease were healed after 8 weeks. Tested manufacturers claim at alpha 0.1 level of significance. So same word problem, just that some of my numbers are different, but you see how they give you the information. And let's see how we can translate that. So we're looking at a percentage. Yeah. So that's why I have P here. And we're looking at our alpha, not alpha, our null hypothesis and our alternative hypothesis. Once again, this will be equal all the time. And the value we're looking at is 0.94. The problem we just was looking at was 89. Mine was 0.94 when I did the problem. So 94%. Both of those have 94%. And then we wanted more than, it says, the manufacturer of the drug claims that more than 94% of patients taking the drug were healed within 8 weeks. So that's why I have greater than right here. Because it said more than 94%. Any questions on the hypothesis testing? I mean, hypothesis setup. What a null hypothesis is and what an alternative hypothesis is. And then because it says more than, that means our test is right tailed. All right. Right here in the green is testing, our ability to have that normal approximation as n times p naught times 1 minus p naught. So 225 was our sample size. It told us 214 out of 225. So that's our sample size. P naught was the 94.94, and then 1 minus 0.94. That gives us 12.69. So that is that's greater than or equal to 10. So we're good to go. And then to find p hat, it says 214 out of this 225. So you do 214 divided by 225, which is 0.95, 1 repeat. Any questions? All right. So now we need to find our test statistic, Z naught. And that's calculated by doing p hat minus p naught over p naught, the square root of p naught times 1 minus p naught over n. Right down the green and the purple. So that's the calculation there. Plugging in values and doing our calculation. Ends up giving us 0.70. Don't forget our z-scores. Always round to 2 decimal places. All right, everybody good? So z-score is 0.7. And then alpha is 0.1. So now we're going to do the classical approach. What we've done up to this point was the p-value approach. This was the classical approach. Now, before we go past the red, we'll just see what we did as far as notation is concerned. So alpha is 0.1. So Z alpha is going to be 1.28. We should be able to get that from our charts. Hold on, the Z-score chart. All right. All right, so if you go to the Z-score chart that we have from our book and we go down here, whoa, down here is bottom corner. All right. So, and I think I've sent this to you already. I thought I did. Of course, correct me if I'm wrong. But if not, it's in the back of the book. But I'll just send it with the other one that I was gonna say just in case. So notice it has alphas right here and our 3 options for alpha. And then up here are 3 different tests. So it says if alpha is 0.1 and I have right tail, I should be looking at, I should circle this, right tail. So I should be looking at 0.128. So that's where I got a 0.128 from. All right. Questions on that? Once again, alpha is 0.1 and I have a right tail test. So that's why I have 0.128. So this is our critical value. So, yeah, that's where it came from, just a critical value from the Z-score chart. So now we can compare. So we compare those 2 values, and if you go back to your Z-score, not Z-score, but your hypothesis testing, whenever we're using the classical approach, we can compare those 2 values, compare the critical value with the test statistic. So if you're using the p-value approach, then you're using that p-value in comparison to alpha. But if you're using the classical approach, then you're going to compare that critical value to the test statistic. So it just depends on which one MyMathLab either makes you do, because they may be telling you, like, remember the other one as said, what is the p-value? Well, if you find the p-value, then you're not using this approach over here, or whichever one you decide to use. So if you decide to use the p-value approach or decide to use the classical approach, it doesn't matter. Still should give you the same result. So I chose to do the classical approach in that case, just to give you an example of how you would do it. So notice down here, if it's 2 tail, left tail, or right tail. Now we're dealing with right tail. So it says if your Z naught is greater than Z alpha, then you reject the null hypothesis. So it's all about getting used to these steps and following the steps as they are set before you. So Z naught, our test statistic is 0.7, is less than Z alpha, which is 1.28. So we do not reject the null hypothesis. Questions. Very good, very straight. So that would be your test, how you would do them. I need to get these steps to you so you can practice those. So from this point forward, we have, what today is 10-4. Next class will be 10-6. We have 10-11, 10-13. All right, so this is what we have left. We just did 10-4 today. So 10-6 and 10-11 will be review days. 10-13 our final exam. And let's see, do I have, yeah, I think I can move it to 10-8. So everything is due 10-8. That should be Monday. Let me confirm. Yep. So everything is due Monday, October 18th. So I will, if I haven't changed it in MATLAB yet, I will do so. Because I think I had it for Sunday, which is 10-17. So I'll give you to that last day to get everything in. There's no class on that day because we would already be finished. So you don't have to meet with me, which everything is due in MATLAB. So we're gonna take our final exam here. And don't forget, if you don't score, you know, what you like, what you would like, there will be a final exam makeup. But the highest score on that will be 75%, you know, in all fairness to, you know, the actual final exam process. And for those who've already taken the final exam and scored, you know, whatever they scored. So basically that final exam makeup will be for anyone who didn't score at least a C and they want to try to do better and get that score that they like, that they would like. So that's why we're taking the final exam here to give you time to take advantage of that. We took the final exam here, then there's no room for, you know, this course is over the next day. I got to get grades in on 10-19. All right, so questions on what we're doing. So let me say this too. If you're going to take advantage of the makeup, you are expected to take the final exam itself first. So that's not a day that you have to come in to a room or anything like that. It's still going to be through Zoom. You will come in at the appointed time, which is what, 12:30 for us, and then you'll have 2 hours to you know, knock that out, you know, and then go from there. You will come, you know, enable your cameras, and I'll send that, you know, send all this in writing as well. But you will come and enable your camera so that I can see you, show your ID to the camera, and then stay on for the duration of the test. Once you're done, you can just log off, you know, hit submit and then log off, and then you'll be done. Then from there, it's just making sure you have everything submitted by the end of 10-18. All right. Questions on anything?
One at a time, like showing on the screen the questions, or
No, on the screen, you mean your ID?
no, I'm talking about like the questions for the final exam. Are you one at a time showing the questions, or where?
No, you would just log into MATLAB and the final exam will be up there and you'll go into it. So basically it will be password protected. And,
Okay.
and then what happened is when you enable your camera, show me your ID, I will type the password to you, and then you will type that into MATLAB, the final exam, and then it will let you in. So I haven't posted it yet, but when I post it, even if you click on it right now before exam, it will ask you for the password. You wouldn't have that password until you come in on class day, and I'll give you the password, and then you will take your test, you know, through MATLAB.
Okay, and then we're on Zoom the whole time with our camera, right? Because I don't know, is that the same thing with the lockdown browser? That's what I was asking before. It was kind of
Okay.
confusing.
Yeah, so there will not be a lockdown browser. So you will have the freedom to use whatever you used in your homeworks, you be able to use it on your final exam as well. But yeah, so when you not log on, but when you enable your camera, if you don't close out Zoom, even if you go to another window, I'll still be able to see you. And so you can minimize it and everything. I still should be able to see you. You would just be working on something else. As long as you don't close out Zoom, then your camera will be enabled.
Okay, and then one thing too, is it okay that I use my iPad? Because that's what I do. I have my notebook, I have my iPad, it's different stuff that I use. Is
Oh,
that-
that's cheating. No, I'm just playing. No, that's fine.
Okay, I was just making sure because I'm hold up. Look.
Yep, not a problem. That's not a problem at all.
Okay.
And then somebody said, what sections are the final? So your final exam is cumulative. So I have a final exam review. Let's make sure it's already posted. Yep, the final exam review has already been posted. And so it really starts from chapter 2. Didn't really pull anything from chapter 1. I think I only pulled like a couple of graphs out of chapter 2. But check out that final exam review. It's not mandatory for you to do, but you should at least take a look at it so you'll know what will be on the final exam itself. Yeah. So you have 2 homework assignments from out of chapter 2, chapter 10, which is 10.1 and 10.2, just practicing what we just finished talking about. But there is not a separate test for chapter 10. Just a few problems from chapter 10 will be on that final exam. So there's not a separate test for chapter 10. That content will be on your final exam. So once again, check out the final exam review. The next few classes, you'll be able to ask whatever questions you want to ask. Check out the final exam review and see if you have any questions on it, so you'll know what you need to ask on the next 2 days. I'll just come to class. I will not have any more new material for you guys the next 2 days, and I will just come here and just answer whatever questions you have. If you don't have any questions, I won't have anything else for you. So it's really about you coming to class. Even if you don't have a question, but you say, I was working on problem such and such, I don't know how to do it. That's good enough. We can address that problem. It's not a problem, but you have to bring them to me so we'll know what to talk about. All right. Anything else? Anybody else before we close out? Everybody straight? All right. So let's look to close out this class well. Close it out strong. We only have a couple weeks left, but at least we have no more new material to worry about. And it's really all it really is about, closing out the class. So once again, let you guys bring your questions, whatever you got, I'll address, and we'll go from there. All right, you guys have a good one, and I'll see you on next class.
You too. Have a good rest of your afternoon.
Take care.
Thanks, you the same. Take care.